Okay, good morning, everybody. My name is Karlheinz Meier. I'm from the Human Brain Project. I'm in charge of the neuromorphic computing activity. I have been at this workshop from the beginning. It's a very nice event, and before I give my presentation here, I would like to point to those two microphones in the middle there. They are very important. In the previous workshops, we had extremely good discussions, panel discussions, which were really steered by contributions from the audience. So when the real talks start later, when the science starts and the technology, please make good use of these microphones and contribute to the discussions. And I have to say something else. We are always running out of time at this workshop. So to all the speakers, please stick to your time, otherwise we have to enforce it. We really need the time to get into these discussion sessions, which are the real important parts of this workshop. So this is a round of funding agencies in a way, okay, or program managers. I'm neither a program manager nor a funding agency. I'm using funds. I'm not distributing them, okay? So I'm the wrong person to be here in this programmatic panel. On the other hand, Europe is far away, so Brussels didn't send a person, so I have to do it. I'll do my best, but it's not what I like to do. But in any case, so this is about European funding for neuromorphic computing and related areas. Let me also, from the beginning, say that this is far, far, far from being complete. I mean, Europe is a very complex structure, as you know, and there is a lot of national funding, regional funding, local funding. I mean, it would require several workshops to really explain to a full extent where the money for research and technology comes from, in particular also for neuromorphic computing. So I'm only giving you the European perspective here. The Human Brain Project, of course, is kind of very visible to the good and to the bad, and it's also very present here. The good part is present here, the neuromorphic computing. So there are, how many? I think 8 contributions which I would advertise here, and they describe many things, like, for example, the hardware development, which I find quite impressive. So there are talks by Steve Ferber and Johannes Schemmel on the 2 hardware development lines, which will also be described in other talks here, and also for the brain scale system, they will be demonstrated out there. So please go and have a look. This is reality. I mean, these things really are existing now on a relatively large scale. And another aspect of neuromorphic computing is, of course, not only to build machines, but to give them something to do that is relevant for cognitive computing, for example. And so there's a lot of theory activity going on, and there are several contributions on theory from Wolfgang Maaß, Mihai Petrovic, there's a poster from Lucy Weiling. And the other thing is benchmarking. Of course, we always said that, I mean, is neuromorphic computing better? Is the brain better than a computer? Not always. Try to multiply 2 5-digit numbers. You are much, much worse than a computer, definitely, even worse than your cell phone. So the brain is not always better. I mean, there are certain tasks that the brain can do, for example, finding structure, spatial temporal structure in data. That's what the brain can do. And so we need specific benchmark that really tell us how good these neuromorphic architectures are. And that's far from being trivial. And Thomas Nowotny I think he will actually be the first speaker at this workshop. So this is the present of HBP at the conference. Coming to the bureaucracy aspect, or the funding aspect, which at the end is important, of course, this is how Europe spends money in Horizon 2020, which is the name of what people call the framework program, has started in 2014 very recently and will run until 2020. That's project start date. So effectively it will run until 2023, like HBP, for example. There is an area, so that's 80 billion euros, basically, that's being spent. There is what's called excellence in science, which is 24 billion euros. Most of this actually goes to individual researcher support, which is also important. Relatively little goes into collaborative effort, like the Human Brain Project, for example. So the so-called ERC grants are 13 billion for this period, which is quite substantial. Future emerging technologies, those are the collaborative efforts where HBP is part of it, but only one part of it. That's 2.7. Then FED has several schemes, like an open scheme, a proactive scheme, and the flagship activity. Open means you can submit proposals for whatever you like, as long as it is somehow technology related. Proactive means committees make proposals on which areas are important, and the flagships are what they are. I mean, they are the big units. So there are two of them, graphene and the Human Brain Project. You see the numbers are getting smaller now. And for neuromorphic computing, these are approximate numbers. There is about 30 million euros foreseen, which is not huge, but substantial, and we can do interesting things. These are the three schemes, open, proactive, and flagships. I don't have to go into details there, but I mean, just to tell you, it's not only the HBP where novel computing can be done. I mean, there is, for example, these proactive schemes where they have work areas, and you see, for example, cognitive neurotechnologies and new computing paradigms and their technologies are explicitly mentioned there. So for those who are not in HBP in Europe, there is still funding to come up with new ideas, which is very important, that you not focus everything on just one project, which may fail or be less successful than you hope for. And so there always has to be alternative solutions or alternative ways. The road to the Human Brain Project, very shortly, I mean, the project hasn't been invented just within a day or so, or not even within a year, but it's really a rather well-coordinated effort that has been running since 2005. And there were several projects funded by the European Commission, like Facets and Brainscales, which led into this large-scale project. And in addition, there were national projects, like the Blue Brain Project or the Spinnaker Project in the UK, and they all contributed to this coordinated effort now, which is the Human Brain Project, which is really important. It has really grown from knowledge and from capabilities, from technological capabilities. It has not just been invented like that. So funding and contractual structure, that's a bit complicated, but I think I'm supposed to say this very shortly. There are several phases. There was a pilot phase. We are in a ramp-up phase now, which has a funding or had a funding of 54 million euros. It will end at the end of this month, in a couple of days, actually. And that was still funded through the previous framework program. And now we are entering in a phase where they have so-called specific grant agreements, where we have, unfortunately, very short periods of 24 months that are being funded with typically 100 million euros. Of course, that's for the entire project, not only for neuromorphic computing. That's funded in the new program. And there is a very, very important thing, which people often underestimate the importance, which is what's called a framework partnership agreement. There are all these horrible abbreviations. I really hate them, but this is an important one. Okay, there's a book which looks like this. You can look at it on the web. It's called the Framework Partnership Agreement. What is this? This is a research and technology plan for HBP reaching until 2023. So this is our roadmap. Okay, it doesn't come with any funding, but that's not so important at the moment. It means that the European Commission commits itself to support this kind of research as it is described in this book. All right, and this is signed by the blood of European commissioners. So this is a relatively stable thing. And this is really what we can point to until 2023. And this is the first time ever I have seen a document like that for this field of research. So it's extremely important. And it has an emphasis on building infrastructures and operate them, make them available to users, and identifying and supporting users. That may also be your path into the project if you're interested. What do I mean by that? Very concretely, this is what exists today. If you go to Europe today, to Manchester and Heidelberg, you find these two monsters. These are two machines that have been constructed over the last 30 months, actually. Of course, they weren't developed out of nothing. I will come to that in my later talk and also in the presentations that you will see. But these machines are available now. And on the 22nd of March, which is very, very soon, we will have a web-based workshop where you can dial in and learn what these machines do, how they work, and what kind of applications you can run on them. So this is sort of one of the first very concrete output of the Human Brain Project. And to operate these machines and to make use of those machines is one of the main work we are going to do for the next years, of course. And in parallel, we are developing the upgrades, the next generation chips. And there will be many talks, as I said, in this workshop. If you want to see where this is, there's a very obvious URL, which is neuromorphic.eu. Just go there and you will find everything about this workshop. That's what I had to say. Thank you very much.